Quadratics, page 20. I'm going to do the last problem, number 8. Infinitely many rectangles may be inscribed within the right-angled triangle shown alongside. One of them is illustrated. Let AB equals x and BC equals y. So I put AB equals x and BC equals y. Let me use a pen here. AB equals x, BC equals y. Use similar triangles to find y in terms of x. Okay, so can you see that this triangle here is a big version of this smaller triangle here and this smaller triangle here? So there's 3 triangles here, a big one, and there's 2 smaller ones that are white. So all of them have the same proportions. In addition, they made it easy for us because they made, you remember 3, 4, 5 right triangles? In the proportion, the 2 sides are 3 and 4 and the hypotenuse is 5. Well, they gave us one of those, so it's 6, 8, 10. It's a 3, 4, 5 triangle. So what we're going to do is we're going to write, we're going to use the fact that this side is 8 and that we know that this is x, and we know we can figure this out from this. Okay, since it's a 3, these are all 3, 4, 5 triangles, so if this shorter side is 3, then this longer side must be the proportion 4. So we can divide y by 3 and multiply by 4 to get this proportion. Okay, so if this is y, we know that this is 4/3 y. Just like if this is 6, we know that this is 8. Okay, to get 6, we start with 6. To get 8, we would multiply times 4/3. Same thing with y. If we start with y, this would be 4/3 y. So we know that this part here is x, and this part here is 4/3 y. So we can add x and 4/3 y together, and we should get 8. Okay, and like on this side here, it's the opposite. We know that this side is 6, and we can add together y here, and then a proportion of x to get 6. And so we could write the equation y plus 3/4 x, because we know that the long side of the triangle, if it's 8, we multiply times 3/4 to get 6. If it's x, we multiply 3/4 to get 3/4 x. Okay? So we're going to use this one because it's more convenient to, actually, you know, if you like, these 2 equations are equivalent, so we can check that out in class. But so we are going to do the first part, which is use similar triangles to find y in terms of x. So y equals 6 minus 3/4 x. All we did was subtract 3/4 x from both sides. Okay? So y equals 6 minus 3/4 x, okay? And so we finished A. B says, find the dimensions of the rectangle ABCD of maximum area. So the area of the green rectangle is A equals xy. How do we maximize that? Well, x and y are related, so we're going to use that fact to put this in one variable only. So we're going to substitute in y equals 6 minus 3/4 x in for y, and then we have only x's left. So we're going to have x times 6 minus 3/4 x. We'll multiply it out, 6x minus 3/4 x squared. This is a parabola, and not only that, it's an upside down parabola because it's got a negative here. So the way you maximize an upside down parabola is you find the vertex. The vertex is at the axis of symmetry. The axis of symmetry you can write as negative b over 2a. In this case, this is kind of tricky because, look, the x squared term is the one multiplied times a. So a is actually negative 3/4. B is 6. So a, we're going to put negative 3/4, and b, we're going to put 6. And so negative 6 over 2 times negative 3/4. Negative 6 over negative 3/2. Remember, when you divide by a fraction, you invert and multiply. So instead of negative 3/2 in the bottom, you're going to put 2/3, okay? And then you just have have 6 times 2 divided by 3 equals 4, and the negative signs canceled out, right? So x is equal to 4. What's y equal to? Well, we just substituted back into the equation 6 minus 3/4 x. When you put 4 in there, you're going to get 6 minus 3/4 times 4th. So these cancel out. You have 6 minus 3, and the answer is 3, y equals 3. Oh, and let's go back and look at this. These two I said were equivalent. If you want to take this one and get this one, all you do is multiply the whole thing by 3. So if you multiply the whole thing by 3, both sides, you get 4y plus, you multiply the whole thing by 4/3. Okay? So if you multiply the whole thing by, you multiply the whole thing by 3/4. If you multiply the whole thing by 3/4, the left side is going to be y plus 3/4 x equals 6. And you can see that that's the same as that. So these are like the exact same equation. So regardless of whether you analyze the vertical side or the horizontal side, you end up with the same xy relationship, which is here, okay? And then you use that to analyze where the maximum is going to be for the area.